All right, we are going to pick up here graphing quadratic equations still. Today what we are going to really talk about is the difference between the quadratic equations versus the linear equations, and also how do we tell the difference? What does it look like using a graph, using a t-table, what have you? What do the equations look like differently? That way we know exactly how to work through that process. Okay, so we're going to start in looking at quadratic equations versus linear equations. So when we look at a quadratic equation, let's just talk graph for a second. So the graph of a quadratic equation, remember, is a parabola, which is a U-shaped graph. So our graph typically is going to look like this. Okay? Compared to a linear, the graph is a line. So you're going to be looking something along those lines. Okay? We have two different equations that we've learned for quadratics. We have our standard form, y equals ax squared plus bx plus c. We've also learned our vertex form, y equals a times the quantity x minus h squared plus k. The thing that makes it a quadratic is the fact that there is a square there. So our highest exponent that is being used is a square, a second power. So therefore, that is causing it to be a quadratic. On the other side, we have our linears. Remember, we learned really two formulas that we use, two equations. We had slope-intercept form, y equals mx plus b, and we had standard form, ax plus by equals c. And if you notice the difference here, this one does not have any exponents. So when you look at your x, see how there's just x? Here you look, x and y, none of them have an exponent of 2. So that makes it a linear function. All right, next, if we have a t-table. So the difference here is if we have a t-table, what we're going to be looking at is what would give me a common difference or a common second difference. So let's take a look at those just real quick here. So how do we know the difference between a common difference and a common second difference? Well, the first thing you should realize is in the name itself, difference. Remember, difference means subtraction. So if I just put the x values 0, 1, 2, and 3, and let's say on this one, let's go 3, 4, 7, and 12. And over here, let's just go 3, 6, 9, and 12. Okay, so how we do this process is, remember, what we're doing is subtracting. So I'm going to come over here and I'm going to say, okay, 4 minus 3, well, that's 1. 7 minus 4, that's 3. And 12 minus 7, that's 5. Well, if you notice, nothing's common there. So the next thing I'm going to do is I'm going to go 3 minus 1, that's 2. 5 minus 3, that's 2. So if you notice, that gave me the same number. That is what we are referring to when we say a second common difference. So it doesn't happen on the first subtraction, but when we take those differences and subtract them again, that's what tells me it is a quadratic. Compared to over on this side, when I start here, I go 6 minus 3, that's 3, 9 minus 6, that's 3, and 12 minus 9, that's 3. And if you notice, you get the same difference for all three, and that is what we refer to as a common difference. Okay, so if we're given a set of ordered pairs or a t-table, that's how we can do that. If we're given a graph, we should easily be able to spot the difference of those. Okay, so what we're going to do is we're going to try some problems, and what I would like you to do is just simply tell me linear, quadratic, or neither. Okay, so we're going to start on a graph. So if I look at this graph, remember that our quadratic equation is in the U shape. Our linear is in a line. Okay, so when I look at this first one, it is neither one of those pictures. So the first one here is a neither. The second one over here, I have this line going, so this is a linear. The one in the bottom left here, if you notice, that is the U shape. That is a parabola, but it's upside down, so that would make that a quadratic. And this last one, if you notice, kind of looks like the U, but it has a point. It's a V shape, so that would be neither. But we did study that graph already. Hopefully you realize that is an absolute value graph. Okay, so that's how we can determine that just from looking at the graph itself. Now let's take a look at from a t-table. So what I'm going to do here is I'm going to start in and I'm going to find my differences. So I'm going to start and I'm going to say, okay, 1 minus 4, and that would be a negative 3. 0 minus 1, that would be a negative 1. And then 1 minus 0, that's a 1. Well, if I look, none of those numbers are the same, right? So I don't have that number. So now I'm going to take and I am going to do the second difference to test that. So I have negative 1 minus negative 3. And remember, we make that plus a positive. Well, that will equal 2. And then we have 1 minus a negative 1. Make that plus a positive. That will equal 2. So that has a common second difference. So that is what we would call a quadratic. So this first one is a quadratic. So now let's try the second. Okay, so we start in and we say, okay, 1 minus 0, and that's 1. 8 minus 1, that's 7. 27 minus 8, and that's 19. Well, not the first difference. So now we try the next one. We go 7 minus 1, that's 6. 19 minus 7, that's 12. Those are not the same, so this would be a neither. Okay, and on this last one, we try it again, and we simply go negative 2 minus negative 4. Remember, go plus a positive, and that's 2. And then we come over here, and we go 0 minus negative 2, plus a positive, and that's 2. And 2 minus 0, that's 2. So if you notice, these all have a common difference. So that means that this third one is a linear. And that's what we are just testing today. We're just looking at graphs and t-tables and trying to see which one would give us a quadratic relationship compared to which one would give us a linear relationship.